मार्क्स से रह गई। बायोलॉजी ठीक था, केमिस्ट्री भी, पर फिजिक्स वो फिसल गया। इस बार पढ़ाई नहीं, तैयारी करो, वो भी स्मार्ट तरीके से, क्योंकि इन्फिनिटी लर्न लाए हैं अट्रेया, इंडियाज मोस्ट पावरफुल नीट रिपीटर्स प्रोग्राम विद p²cb, जिससे फिजिक्स पे होगा डबल फोकस। डोंट जस्ट मेक इट योर लास्ट ट्राई, मेक इट योर बेस्ट वन येट। Join Infinity Learn today.
Hello my dear students, welcome to one more amazing session from Infinity Learn. This is Suresh, Faculty of Chemistry. How are you all? Can you all able to hear me? Can see me? Just give a confirmation in the chat box. So welcome to one more amazing session. In this session we are going to discuss about chemical bonding, more about the hybridization. I have very good tricks to resolve problems from the hybridization, and stay tuned, we are going to give simple amazing tricks and with the content related total explanation of hybridization, the shape of the molecule and the chemical bonding overview. Hi Manisha, how are you? Please confirm you are all able to hear me, you are all able to see me. So once you confirm, you can start the class without any delay. And आज का क्लास है chemical bonding. It is more about VSEPR theory and valence bond theory, conditions for overlapping and different types of overlapping, and also hybridization and formula to calculate hybridization. बच्चों, hi Manisha, confirm you can see me and hear me, so that the streamline is there, right? Okay, so before going for the session, I just want to introduce you. Yeah, we are able to hear you and see that. Thank you Manisha, and we'll see little promotion before we start the content. That is Atreya program. So crack your NEET examination, and this particular session is meant for the NEET examination aspiring students. And you can, as this topic is about chemical bonding, those who are studying 11th standard can attend this class. Those who are studying 12th standard can attend this class, and those who has taken the drop and can attend this class. Just speak loudly. Yes, is my voice is okay? Manisha, is my voice is okay? Now let's see. So when you prepare your NEET examination, 2025 NEET examination is completed, and if you done well, all the best and congratulations. And by any factor you are not able to solve and you are not able to crack, here the Atreya program, and we are introducing this Atreya program. We are going to change your state from I didn't do to I will do it, and crack your NEET examination by using Atreya program. It is the India's most powerful NEET repeaters program. In this program you have p²cb physics twice a day along with chemistry and biology. And enroll now, and details are there in the description box, and you can click it and explore the details. And also you can see, I just want to give you the outlines of this, and it is a revolutionizing NEET preparation program for the droppers. And the program details, batch commenced a long ago, May 23rd. And also you see, this batch is every week one new batch is being added. So if you enroll, you are going to join in a new batch, no worries. And your days of the week with the classes are going to be Monday to Saturday. Every day classes will be there. Sunday chutti hai, and each day 3 classes hai. 2 concept classes, 1 practice session, and also each class is 1 hour 30 minutes, 90 minutes का, ये 1.5 घंटे में आप ज़्यादा कर सकते हैं. And also you can have 18 classes per week, and उसमें important is a double practice class for physics. You know, physics has given a slap like anything. In that you can see, physics we want to take it as a challenge. Physics is a doubtful subject, and it is going to be a nightmare for every student. And from now onwards, physics is on us, and we are going to take you out from the difficulty level to easy level. Yes, stay tuned. And also you can have in this Atreya program 465 classes in the total package you are going to have 240 DPPs and dedicated practice classes, 120 dedicated practice classes बच्चों. And after class you are going to get a PDF format of these notes. Automatically it will be reflected in your portal, and also you can see batch size for the practice class is 20 to 25. This is very important. You will not be placed in one of the student in 100 class. You will be placed in a small class where you are directly going to connect with the faculty. So a customized doubt clarification facility is also available when this strength is very less, है ना? And also बच्चों, it is going to be total coverage of NEET and 12th and 11th syllabus will be covered there, and my promotion is over. And last, if you complete your NEET 2025, if you get some result, and please enter the result ताकि आपको पता चलेगा आपका अगर क्वेश्चन and medical seat कहाँ आने वाला है. Rank predictor is there. You can just click in the description box. The link is available. So mine is done, and we are entering into the concept of chemical bonding. बच्चों, in the topics that are there in the Lewis electron valent theory and also ionic bond and covalent bond and VSEPR theory and VBT valence bond theory, hybridization, molecular orbital theory and bond parameters, hydrogen bonding and bond parameters. So in this sequence of these topics, it's very important to the total chemistry. It is connected with both inorganic chemistry and organic chemistry. If you are very good at a periodic table and chemical bonding, you can handle any organic and inorganic chemistry concepts. So it is very important. So we completed Lewis octet theory in the previous lectures. If you have any doubts, you can just watch the last videos. Ionic bond is completed, covalent bond is completed, and VSEPR theory is completed. And connecting to this, we are going to talk about VSEPR theory and VBT hybridization. These three are going to be discussed in today's class of agenda. And अगले क्लास आपको देने वाला है, पेश कर रहा हूँ, and molecular orbital theory, hydrogen bonding and bond parameters बहुत important चीज का है. And बच्चों, Manisha, let us start with the chemical bonding. You have in introduction of the bonding. So what bond and how the bonding is taking place, there are major theories are there. We have Lewis concept, Lewis electronic theory of valency. Stay tuned and you can just write the noteworthy points, then you can do the best. And VBT and VSEPR theory and MOT, right? So today's concept is going to be valence bond theory, and let us discuss about these theories in a sequential varies. Okay, bachcho, get ready, take a pen and paper, write noteworthy points. I'm not asking you to write the total notes. Okay, in the Telegram channel, the notes is going to be given automatically in the PDF form. You can download it. Okay, now bachcho. So the formal charge is also completed in the previous class. The formal charge of the atoms in the given formula structure of the molecule that can be calculated by using the formula. Formal charge is equal to Na minus NLP plus half NB. What is this? Number of electrons in the valency shell of the bonded atom and minus number of unpaired electrons, lone pairs, minus half into number of bond pairs. So the sum of the formal charge for the neutral molecule is going to be 0, and for a charged ion it is equal to the charge on the ion. And why this formal charge is that important? So when you write the Lewis structures are imaginary structures, and these imaginary structures may be correct or may be wrong. For that you can write more than one kind of structures, that is called resonating structures. So the possible way of correct resonating structures can be cross-checked by using this formal charge. Bachcho, this is very important. So every point I am giving you, it is a worthy, and in this NEET YouTube channel from Infinity Learn, we are giving the actual genuine content, and we don't want to conduct this for the fun sake or to make these advertisement sake. So please take these lessons in a very meticulous way, and please like the session and share with your friends. Subscribe to Infinity Land NEET YouTube channel. एक बार like बताओ, like दबाओ Manisha. And this particular session is going to be a live interactive session, ताकि आपको chat box में you can ask a question to me and I can discuss with you. It is a two-way interaction, and it is not a radio telecast session so that you can just watch and leave. Okay, just get advantage of this, bacho. Here you can see the formal charges. So oxygen, and this is a ozone molecule, bacho. This is a ozone molecule. Oxygen single bonded with oxygen and double bonded with oxygen. There are three types of oxygen. This is oxygen number 1, this is oxygen number 2, and this is oxygen number 3. In these three, you can say oxygen number 1 has 3 lone pairs of electrons in it. Oxygen 2 has just 2 lone pairs of electron. Oxygen 3 has 2 lone pairs of electron. So let us apply formal charge formula for this. For this formal charge on this atom number 1, iska 6 minus 6 minus 1 by 2 into 2, bond pairs are 2, and it is going to be, formal charge is going to be minus 1. And if you take formal charge for the second, it is going to be 6 minus 2 minus 1 by 2 into 6, because it has 3 bonds. So 3 bonds means 6 electrons are there. It is going to be plus 1. While the oxygen number 3, you are going to say 6 minus 4 minus half into 1 by 4. So 1 by 2 into 4. So why 4? It has 2 bonds. 2 bonds means it is involved in 2 bond pairs of electrons. So it is going to be 0. When you take the sum of these 3 is going to be 0, ताकि इसका oxygen neutrally होगा, and it can have minus 1 and plus 1. So for that it can have various resonating structures like this. Okay, oxygen double bond O and O minus and plus, and is going to have the oxygen double bond O and O minus and plus. And the resonance hybrid is going to be O, and there is a partial bond. Okay, so this is going to be the ozone resonating structure. If you have any doubt, please let me know. Similarly, this is a carbonate ion. In this Lewis dot structure, this carbonate ion is given by the various resonating structures. You want me to show the various resonating structures of carbonate ion? Bacho, you just see the same structure. Resonating structures, or the structures are imaginary. Actually, to explain all the properties of a molecule, single Lewis structure like this may not be sufficient. So that more than one kind of structure, one structure has to be provided. But none of this structure is going to explain the total properties of the molecule. And actual molecule exists as a hybrid of all these structures. And each structure is called as a resonating structure, and the hybrid is called as a resonance hybrid. And this phenomena is known as a resonance. You can see the resonating structure of carbonate ion, C double bond O and O minus and O minus, and it is going to be C double bond O, and it is going to be O minus and O minus, and it is going to be C double bond O, and it is going to be O minus and O minus, and the resonance hybrid is going to be single bond pakka, but a double bond is moving here and there. So this is the overall structure of carbonate ion. Are you getting or not? It is a planar, trigonal in shape. So take this advantage of these lectures. Please follow the lectures, and then going to give you super awesome points. And you can draw the compounds. And can you identify the lone pairs of electron? How many lone pairs of electron? Can you identify the lone pairs of electrons here? And just take the Lewis dot structure of the free atom and give their respective atomic molecules or bonds, and जो भी इलेक्ट्रॉन्स बचा हुआ इसका मीथेन 0 होगा, नाइट्रोजन लोन पेयर ऐसे दिखता, and oxygen 2 lone pairs ऐसे दिखता, 2 lone pairs of there, right? So like that you can see how many lone pairs are there. Understand? Clear? It is very clear. It is very clear. You can do the best. Okay. And moving ahead, how many lone pairs are there? Can you identify how many lone pairs are? Quickly I want to know from chart box. Quickly I want to know from the chart box. Here I can see whenever oxygen is there in a double bond, you can see a pair, one lone pair, okay, and also one more lone pair, and here I can see the lone pair. Identification of lone pairs is very important. It is helpful when you solve the question in the organic chemistry also. Hope you understand. Clear? Please, who are there online, please like the button. So press the button, like button. So I want to see, please encourage the class. Okay, now A plus B combined to gives rise AB a covalent bond or A to B a day2 bond. If it is like this, it may be polar or non-polar. It is going to be obviously polar. This is called coordinate covalent bond. Mutual sharing of electrons is called a covalent bond. A bond where you can see an electron pair is donated by one atom, other one is going to share both the things, is called as a special type of covalent bond, is called as a day2 bond. And covalent bond formed here, right? Now you can see coordinate covalent bond, it is a bond formed by mutual sharing of electrons between two atoms, but the shared pair of electrons is contributed by only the one of the bonded atom. He is called as a coordinate covalent bond or coordinate bond or day2 bond. Okay, bachcho, NH4 molecule, you can see the NH4 molecule, NH4 plus ion, ammonium ion, this is ammonia, and the lone pair of electron present in the ammonia of the nitrogen is going to give rise a proton, H plus to gives rise ammonium ion. So this is called day2 bond. You can also see the hydronium ion H3O plus. This is a hydronium ion H3O plus is also said to be an aqueous acid. In this aqueous acid, water molecule is there. So don't say it is a bent or linear, okay. So this is a Lewis structure, bachcho. It is not able to explain the shape of the molecule. So no worries here. The lone pair of electron present on the oxygen of the water molecule is given to the H plus of the acid, so that you are going to get H3O plus. This is called hydronium ion. Okay. So you can see various example. Coordinate bond, it is very important bond. Now exceptions to the octet rule. Does every atom, every molecule octet rule is participated or accepted and followed? It may or may not. So why? And it is not actually explained by Lewis theory. So certain stable molecules still they are not participating and involved following octet rule. Let me give you an example here. BF3, you can see BF3, boron has its own molecules like this. You can say boron, it has 1, 2, 3, 4, 5, 6. It has only 6 electrons. BeCl2, it has only 4. So such molecules are not following octet rule. Such molecules are not following octet rule. So still they are stable. Lewis theory cannot explain the stability of this. But the molecules which has less than 8 electrons in the bonding is said to be electron deficient compounds or hypovalent or octet insufficient molecule. So electrons around central atom is less than 8. You can say 6 and 4. So such are called hypovalent. They are called as hypovalent or octet insufficient. So in-depth expression, I will start 11th this year. Yes, this is a 11th concept. Waiting for the college selection, definitely whatsoever the college you are studying, better, you can just follow the lectures, and these lectures are super important. Okay, talking about here odd electron species B hai, molecules with odd electron species. So electrons are always in the pairs, so that pair is an even number. But sometimes you can see there is an odd number. Example, you can see nitric oxide NO, and you can see nitrogen dioxide, you can see there is an odd electron over here and there is an odd electron over here. Okay, so these are the octet species, odd electrons you can see. So Lewis theory cannot explain the odd electron species, molecules with odd electron. Okay, bachcho, in the NEET examination you will be given a question, which of the following is electron deficient, which of the following is hypovalent, which of the following is hypervalent, which of the following is an odd electron species. You should be able to find out what is happening and how it is happening. So in depth express आपका नाम क्या बेटा, and please like the button so that the session should be interesting and encouraging, है ना, जल्दी दबाओ. So when you like the button, that is going to be visualized to me. Now you can see PCl5, it is a superoctet molecule with expanded octet. It is called as a superoctet or hypovalent. Now you can see phosphorus has 5 bonds, means it is going to have 10 electrons. 10 electrons greater than 8 electrons. Of course, it is also not explained. It is also not explained by the Lewis octet rule. Okay, you can say PCl5 has 10 electrons around the phosphorus, right? Okay, now you can see you have XeF2. You are going to see XeF2 structure is like this. Yes, xenon is a noble gas. How come xenon able to participate in bonding? Yes, helium, neon, argon, krypton, xenon. These are all noble gases. They have completely filled shells, so they never participate in the bonding. So helium duplet configuration, neon, argon, krypton, xenon has octet configuration. कभी any chemical reaction में participate करना मुश्किल है. Never. But xenon in extreme conditions, it is going to participate in bonding. Only with oxygen and fluorine. इसका थोड़ा सा exception भी है, क्योंकि Berthelot was a scientist, did experiment, and he found that xenon has ionization energy is equal to molecular oxygen. That is assertion reasoning type question and can be asked in NEET examination, and stay tuned for such type of facts, and it is there in the NCERT P block element group 18 and the class 12. We will be learning everything. So let us say that awesome journey with Infinity Lane for NEET preparation. Yes, definitely I can assure you that. And you can see XeF4BA, xenon is able to participate in the bonding with the fluorine. XeOF4 is also there. Okay, let's discuss about all these things. And other drawbacks you see, other drawbacks of the Lewis theory, drawbacks of the Lewis theory. So Lewis theory cannot explain the relative stability of the molecule. So SO2, SO3, who is more stable? Okay, NaCl and NaF, who is more stable, is not actually explained. Okay, those students who are online, please reply in the chat box if you have any doubts, and please like the session, bacho. And you can say there is a day2 bond, there is a day2 bond, F minus is giving electron to the boron in BF3, you are going to get a BF4 minus. It's a day2 bond in this side. And more examples of the day2 bond here. Ammonia, we already did this. Ammonia boron trifluoride. NH3.BF3 is an adduct, you can say, bacho. And you can see how the bond is formed. You can see more example, NH3. It has a lone pair of electron, you see. The lone pair of electron is given to the vacant orbital of BF3. Boron has a electron deficient compound, iska pass vacant orbital here. And this electron is given to this, so that there is a day2 bond between nitrogen to boron. So that you are going to see the formation of NH3BF3, and it is going to be a day2 bond. He is a donor and is an acceptor. He is a donor and is an acceptor. You know, according to ionic equilibrium, Lewis theory. Electron pair donor is called as Lewis base. Electron pair acceptor is called as a Lewis acid. So the Lewis base should have at least a pair of electron with it, and Lewis acid should have at least a vacant orbital with it. So the electron deficient compounds do have this facility. They are going to be the Lewis acid and acceptors for this day2 bonding. So you try to learn bond kaise banana. Understand? If you have any doubt, please use the chat box, ask me a doubt, so that I am very happy to answer your doubts. So many students are there in the line. Please follow the class, and you can see more examples of coordinate bond. You can see CO is there, O3 is there, HNO3 is there. Now topic of interest is for today's valence bond theory. Today's topic of interest is going to be valence bond theory. And this valence bond theory explains how the bond is formed according to the orbital. And bacho, those who are in online, please like the button, okay, like the session, so that the session is going to be super awesome. I am going to drive you. So when you click the like button, I can see the number is increasing. Hi Sai, you can't understand this valence bond theory in the 11th standard, right? Once you are in the 11th standard, you can understand. If you have any doubts where you miss it, please let me know. Please let me know so that I can explain you. Valence bond theory. Remember what happens when two atoms approach each other. Atoms come close, and they are going to overlap their electron cloud. Hegena, are you getting or not? They are going to overlap, right? So how they are overlapping? Their electron cloud is overlapping. Are electron cloud kahan rehte? Electron cloud lies in their respective orbitals. So let's see the various kinds of orbitals, how they are going to do. So orbital overlapping concept. According to valence bond theory, the partial interpretation of the atomic orbitals. So I just want to say, according to VBT, a covalent bond is formed by the overlapping of the orbital. So an atom and an atom, इसका ऑर्बिटल दोनों मुलाकात करके मिक्स करना है. वो हाइब्रिडेशन से अलग है. Hybridization within the atom should take place. So the shared pair of electrons of the bonded atoms which are present in their respective orbitals can come and overlap together. That's what is called as a covalent bond. So various types of overlapping. So orbital overlapping via covalent bond, or it could be coordinate covalent bond. If you say it is a coordinate covalent bond, bacho, it is a special case of covalent bond only. So it is not a big rocket science. Okay. So in this covalent bond, single electron opposite spin are required. So I want to say this is an atom of this and this is an atom of this, and the electrons that are present here, one should be having an electron and another should be having another electron with a reverse spin. Then only they are going to pair up. Okay, and here empty orbitals, fully filled orbital pair with opposite spin directly given to the empty orbital. So we'll see covalent bond is overlapping orbitals. So it forms, overlapping is of two types. One is a sigma bond, another one is a pi bond. What is the meaning of a sigma bond? It is a axial overlapping. So the bond is formed by the axis of the molecule. I mean, what is the axis? In the molecule, you just take the nucleus of the bonded atom, You draw an imaginary line, that is called bond axis. And this axial overlapping of the overlapping is called as a sigma bond, and pi bond is a lateral overlapping. What is this axial overlapping? This is an orbital along this axis. Another orbital, this is an axis. So there is an overlapping, this is called as a sigma bond. While you take an orbital, this is the bond axis and this is an orbital and this is an orbital. The relation between these two is going to be, it is going to be a pi bond. So side by side overlapping is called as a pi bond. बच्चों अगर कुछ डाउट है ना तो जल्दी पूछना. So we are going to go in the details. Going to give the details. Right. Now you can see s orbital and s orbital is overlapping. That is a sigma bond. So s orbital is a spherical and s orbital is a spherical, and head on overlapping or axial overlapping is called as a sigma bond, right? And in this you can say this is the nucleus and this is the nucleus. In this nucleus you can see, if you draw a line along with the axis and there is a overlapping here, that is called as a sigma bond. Sigma, yes, overlapping, you can simply write it as a sigma s orbital बीच में एक overlapping चलता. It could be other types also, types of sigma bonds. Sigma bond, it could be s orbital and sp orbital and pp overlapping. The overlapping can takes place between the s orbital and s orbital. This is what is s orbital and this is s orbital. ये दोनों का बीच में जो ओवरलैप आता है ना, दिस इज व्हाट इज कॉल्ड एज सिग्मा एस एस ओवरलैपिंग. Sigma s s overlapping. You take here s orbital and p orbital, that is what is called as sp overlapping. S orbital and you are going to see the p orbital. P orbital in dumbbell shape, s orbital is in spherical shape. This is what is called as a sp overlapping. This is what is called as sp overlapping. Understand? Let's talk about the pp overlapping. You can have the p orbital here. You can see the p orbital here, and when the bond is formed by two p orbitals overlapping, it is more directional, so it is called as p overlapping. Understand? Any doubt bachcho? Jaldi. And according to VBT, valence bond theory, a covalent bond is formed by two atoms by overlapping of their atomic orbitals which contain unpaired electrons of opposite spin. Unpaired electrons of opposite spin, then only bond is going to be formed. And more the extent of overlapping, stronger is the bond. Lesser extent of overlapping, weaker is the bond. Of course, sigma bond is a strong bond and a pi bond is going to be a weak bond. My dear students, please follow us. And you can see p orbital say p orbital, and it is a positive lobe and negative lobe, and a positive lobe and negative lobe दोनों मिलके आपका sigma pp overlap होगा. This is what is called a sigma bond between two p orbitals. Okay, so is every overlapping gives you the bond? Does every overlapping gives you the bond? No. Just a minute, bachcho. What are the conditions for the overlapping? What is the condition for overlapping? So orbitals which are overlapping should have nearly the same energy, mind it. And they should have the electrons with opposite spin. You want to say 2p orbital of an atom, 4p orbital of another atom, energy ज़्यादा अंतर होगा. That's the reason why they have the less chance for the bonding. If you have 2p orbital of an atom, 2p orbital of atom, दोनों का बीच में bond होने का संभावना अच्छा तरफ होगा. Understand? Clear? That's good here. Now you can see sigma bond, you can see s orbital and p orbital both will come and make a sigma sp overlapping. Sigma sp overlapping. बच्चों and you can see, talking about the pi bond, when you talk about the pi bond, this is an orbital, this is the nucleus, this is an orbital, this is the nucleus, and these two orbitals are going to combine to give rise a pi bond. This is what is called as a pi bond. This is the bonded nucleus, so this pi bond appears like this. So ये separate करके आपको अलग बना दिया. Pi bond is having a separate split along the internuclear axis. This is the nucleus of the bonded atoms. And sigma bond has a cylindrical symmetry. You can see sigma bond has a cylindrical symmetry. You can assume a cylinder kind of thing over here. And more electron cloud is accumulated between the atoms. While here less electron cloud is there, diffused, so it is a weak bond. Pi bond is a weak bond and a sigma bond is a strong bond. Let's see the more details about this. So sideways overlapping is called as a pi bond, and you can see this is what is called as the pi overlapping, and the d orbitals also can have the overlapping. You can have dyz and dyz orbitals can have the overlapping between these two. So that is called as d pi overlapping. So pi bond between two d orbitals is called as d pi overlapping. Pi bond between the p orbital and d orbital bhi hoga, that is called p pi d pi overlapping. Pi bond between the p orbital and p orbital is called as a p pi bonding. If it is between two atoms within this molecule, if we have the bonded atom gives to the central atom, that is called as the back bonding. That could be between the p orbital and the d orbital. Usually you can see in the third period elements d orbital involvement you can see. D orbital involvement you never see in the second period element, because second period element shell number 2 तक रहेगा. Second shell में d orbital ही नहीं है. D orbital शुरू करने का third shell से शुरू होगा. Right, let's talk about here d pi bonding, and you can say directional properties of the bond. Yes, the overlapping orbital should be in a proper direction ताकि ये overlapping possible है. Otherwise overlapping is not at all possible. So we see here the directional property. All the orbitals overlapping do not result in the bond formation. Those orbitals with the proper appropriate direction only can form participation in the bonding. And you can say pz orbital एक ही डायरेक्शन में हो ये पार्टिसिपेट होगा, ये ओवरलैपिंग सही ओवरलैपिंग है. एंड pz ऑर्बिटल एंड s ऑर्बिटल इज नॉन डायरेक्शनल, सो दोनों का बीच में बॉन्डिंग चलता, इट इज पॉसिबल है. एंड यू कैन सी हियर and py they can participate in the pi bond, and px they are going to participate in the pi bond. And you can say, let's say px orbital, that is a px orbital, and py orbital, ये दोनों का बीच में, this is your py orbital, ये दोनों का बीच में ओवरलैपिंग होगा नहीं होगा. अब बताइए जल्दी. I want to see in the chat box. This chat box is for you, and this is a live interactive session, and this is an expert faculty from Infinity Learn, and you just talk to us and you can clear all your doubts. So to find an expert faculty you want to have this kind of interactive session, you need to go to a coaching industry where you have to pay huge amount of money. So here you need not have to pay, it is a full free of cost, and you can just join the class and make the session awesome. And this is a super advantage. Take this advantage and get a free coaching. Yeah, Atul, yeah, नहीं होगा. अच्छा दिया, आंसर इज नॉट गिवन. सो जहां पर ओवरलैपिंग होता है ना, दैट इज कॉल्ड पॉजिटिव ओवरलैप. That is called as a positive overlap, and it is going to be zero overlap. जब पॉजिटिव ओवरलैप हो तो बॉन्ड इज गोइंग टू बी फॉर्म्ड, and zero overlap bond is not going to be formed. Mind it, and these combinations are going to be a simple logical questions in the NEET multiple choice question. Which of the following is possible? Which of the following is possible way of bond formation? and different kinds of options will be given. You just learn the concept with a lot of confidence and apply this, and getting a top score in the NEET examination is a game, and if you have a proper plan, and you can do it. And be confident beta. Yes, Atul, and let's see here positive overlapping. मैं क्या बोल रहे हैं? And you can say PZ overlapping and PZ and SO overlapping are negative and a positive, है ना? And it is going to be 0, and this is called directional properties. This is called negative overlapping. And negative and a positive, it's a negative overlapping. Negative and a positive, negative overlapping. Okay, and there is no overlapping, that is called zero overlapping. If positive is called positive overlapping, negative positive is called negative overlapping, negative is called again a positive overlapping. Mind it is very important. And you can say this orbital cannot be properly fit into this. This is a directional property. This and py and pz orbitals, they are completely different in their direction, so that they are also not participating. यह overlapping का chance भी नहीं है. Is called as a zero overlapping. Which of the following is zero overlapping? Which of the following is negative overlapping, positive overlapping? This gives you a very good question. Okay, Atul, please like the session. If you like the session, आपको दिखाई दे सकते हैं. And please like the session. I will clear your doubt. They are not overlapping. I will tell you. If I'm taking a shake hand with my friend, right? So we should be in the same axis, right? So the overlapping takes in place. And if I'm here, and my friend is in the different way, so he is in this way. So I can give shake hand like this, and he can give shake hand like this. The direction is not possible. And these two orbitals are there, and these two orbitals can overlap. Yes, direction is permitted, positive overlap. If an orbital is like this, an orbital is like this, this is no chance of getting overlapping. This is what is called as zero overlapping. So zero overlapping kahin nahi hoga, and neither along the molecular axis nor perpendicular to it. So this is a perpendicular to it. So overlapping do not take place. Okay. Got it. Thank you, Atul. So Atul, like mara beta. Next. This is not giving a bond. So cross mar diya na. Got it. Right. So let's see here. Directional properties, types of overlapping based on the direction. There are three directions, like positive overlap, negative overlap, zero overlap. So what is this positive overlap? Here you can see it is allowed, whereas negative overlap, zero overlap, not allowed. Fine. For what? Allowed for bonding, not allowed for the bonding. Allowed for the overlapping, not allowed for the overlapping. And talking about here, very important, extent of overlapping. Extent of overlap. More is the extent of overlapping, stronger is the bond. Less is the extent of overlapping, weaker is the bond. And you can see s orbital is going to form a sigma bond. Bacho, here it is called a sigma ss overlapping. And you can say s orbital and p orbital is going to get sigma sp overlapping. And the p orbital and p orbital you are going to get sigma pp overlapping. This is a sigma. Okay. Now talking about here, strength of sigma bonds. More is the extent of overlapping, stronger is the bond, bacho. You can see strength of sigma bond depends upon SS overlapping is weaker than SP overlapping is weaker than PP overlapping. PP overlapping, why it is a strong? Because more directional, more is going to be the strength of the bond, bacho. And you can see when you talk about the pi bond, comparison of the sigma and pi bond, sigma bond is formed by the axial overlapping, while pi bond it is formed by the side by side overlapping. And sigma bond you can say large extent of overlapping, and you can see the pi bond is going to be the less extent of overlapping. Because of the large extent of overlapping, sigma bond is going to be the strong bond and the pi bond is going to be the weaker as compared to the sigma bond. So when pi bond and sigma bond is there, first you want to break it. So pi bond is going to be first broken, then the sigma bond. Okay, this is about the difference between the sigma bond and the pi bond. Let us say strength of pi bond, you can see 2p pi bonding is stronger than 3p pi bonding. Why? Because it's close to the nucleus, second shell, and is far away from the nucleus, so it is going to be the weaker bond. So like that you can correlate which is more strong bond, which is a less strong bond. Okay, strength of the bond is going to be a very important question for the NEET examination, bacho. Now you can see using VBT to get shapes of the molecule, of course, why not? Sai, why not? You can get it also. Now you can see hydrogen is there, it has one electron in it, right? You can see the animation. It is going to take another hydrogen with opposite spin. Okay, you can take the opposite spin. When these two are going to combine, hydrogen to hydrogen, this electron is going to join with this. So there is a sigma bond between two s orbitals. So it is a sigma bond between this first two overlapping is shown like this. Okay, let us go in details about this. And talking about here oxygen to oxygen formation of oxygen molecule. So there is a px and pz and py orbitals. Okay, px and pz and py orbital. So what happened? Pz orbital, first it is a z axis, two orbitals are going to combine and forms a bond like this. Are you getting or not? Are you getting or not? So pz orbitals are going to form a bond. So this is a z axis. So this is a z axis, and this z axis you can say they are going to combine a sigma bond first. Yeah, Janishiga, you tell your doubt, waiting for your question. Sanjana, it is all about orbital configurations. Okay, Janishiga, and once this orbital is going to form, this is an oxygen and this is an oxygen, two oxygen atoms are combining together, and this is a py orbital perpendicular to that, and a sigma pp bond is formed, and py and py orbitals are there. Now these py orbitals are going to form a pi bond now. So between two oxygen atoms, one sigma bond and one pi bond is formed. This is about the formation of oxygen, right? Now let us talk about the nitrogen, formation of nitrogen. So in the formation of nitrogen, you can say this is a nitrogen 1s2, 2s2, 2p3. So this is a px, okay, this is a py and this is a pz. So if you don't understand, please watch the recording and you can practice the orbital shapes and electronic configuration. If you are not confident in the electronic configuration, you don't understand. That is not your mistake. There is something required to know about the electronic configuration. David Chava, hi. Sanjana, you just follow the electronic configuration, then you watch the recording. Okay? So David and Janishika, I want to know the question from you. And David, please like the button. And one more nitrogen atom का आता है, इसका अलग percentage of S character, Janishika, sp 50%, sp2 it is going to be 33.3% and sp3 25%. In the hybridization concept आपको पता चलेगा Janishika. Okay, now this is about the px and pz and py orbitals. So that pz is going to be z axis. So this is going to be z axis, and in this z axis you are going to form, this is going to be a sigma bond and this is a sigma bond, and this is going to be py and this is going to be pz. So it's going to form a pi bond and this is going to be a pi bond. That's the reason why nitrogen has one sigma bond and two pi bonds like this. So इसमें एक sigma होगा और एक pi होगा और एक pi होगा. Are you getting or not clear? Thank you very much. Please, Janishika, please like the button. Okay, please press the like button. Okay, thank you very much. And this is about the nitrogen, dinitrogen. Let's move ahead with other examples. So, you are going to be the shape of CH4. Here the electronic configuration of carbon is 1s2, okay, 2s2, 2p2 in this ground state. And these two electrons cannot participate in bond with four hydrogen atoms. That's the reason why it is going to excite its electronic configuration. In the excited electronic configuration, बच्चों ये जो electron है ना यहाँ पे jump करने के बाद क्या होगा, यहाँ पे jump. This is an excited electronic configuration. So these four electrons are going to participate in bond with hydrogen to form a methane like this. So for that you need an excitation comes. Where does this excitation comes? So I said this is an electron excited from here to here. Where does this excitation comes? From where you are going to start the question. And that excitation comes the release of energy due to overlap between the orbitals of carbon and the hydrogen. For that is going to have the hybridization. So this hybridization you can see, I will show you various types of hybridization. Shape of CH4 molecule. So you can say it is going to be a tetrahedral molecule and it is going to have 109.5 degrees. Okay, right. Now in this I just want to take you the hybridization now. Limitations of VBT. Yes, VBT is there, it has its own limitation. So it is failed to account the geometry shapes of various molecules. A few molecules it is said, but all the molecules is not. So it is important to know then how can we ascertain their shapes? That is the biggest question. So the shape of the molecule is very, very, very important to decide its physical and chemical properties. Okay, so for that you can say you need hybridization. Okay, we need hybridization. So for that, so orbital when they combine, you are going to see, so you can see the hybridization here. So you can see intuitive approach, when an orbital come and meet together, it is going to reorganize. S orbital and p orbital comes together, it is going to reorganize to form one orbital like this, and this is another orbital. So एक ही orbital जैसे दिखते हैं ना, ये दो orbital अलग अलग orbital, ये ऐसे दिखना है और ये वाला और एक चीज का है. So this is the nucleus, and you can see S orbital and p orbital, there are two s orbital and a p orbital, they are going to have one sp, another sp hybrid orbital, right? And in that way you can see the hybridization is a spontaneous intermixing of the atomic orbitals. Spontaneous intermixing of the atomic orbitals, you can see. Let us discuss about the details of the hybridization. So intermixing of atomic orbitals of equally slightly different energy, equally or slightly different energies to gives the same number and equal number of electrons and orbitals, new set of orbitals of the equivalent energies and the equivalent shape as well. And you can say this is called hybridization. So for hybridization, हमेशा hybridization के लिए excitation चाहिए. Excitation is not an essential condition for hybridization. Okay, now results. Now you see here, remember one thing, 1s and 2s, it cannot mix because energy of these two orbitals is not same. That's the reason why orbital overlapping do not takes place. And you can say 2s and 2p, they can mix because they have the nearly same energy. Mind it, in the NEET examination you will be asking which orbital can have hybridization, which of the orbitals cannot participate in hybridization. Fine. And 3s, 3p, 3d can mix. And you can say 3s, 4d, 5s, they can't mix because they have the different energies. The orbitals with similar energy only can participate in hybridization. Once the hybridization is done, old identity of the atomic orbitals are lost and you are going to get a new identity of the orbitals. So points to remember and silent features, take a pen and paper and quietly write this. So number of hybrid orbitals. Number of orbitals involved in the hybridization should equal to the number of orbitals that are formed after hybridization, and number of orbitals intermixing, and both are supposed to be same. It should be equal, right? So presentation सबको अच्छा लग रहा है ना? Yes, very good. Now you can see here silent features उसमें the energies bond formed by the hybridized orbitals is always strong and than compared to the pure atomic orbitals. What is a pure atomic orbital? आपको जो भी s orbital, p orbital, d orbital है ना, these are atomic orbitals, are also called as the pure orbitals. And also you can say important conditions for hybridization, and orbitals can participate in hybridization in that have a pair of electrons in it, have an unpaired electrons in it, or it can be a vacant orbital in it. So in that condition only hybridization takes place, okay. And you can say when they can form, all three types can undergo hybridization, and these slides are beautifully prepared and it is self-explanatory, okay. And you can see naming of hybrid orbital. How do you name him? It simply, okay, if a person is coming from Canada, you can say Canadian, American, simply like that. You can say here orbitals named according to their orbital name, and you can say on the basis of participating atomic orbitals in the hybridization bachcho. And you can see here s orbital and s p orbital. You can say it is going to be sp hybridization, okay. It is called sp hybrid orbital. It is named like this. And sp, sp2, sp3, sp3d, sp3d2, sp3d3. It is formed by one s orbital and a p orbital. उसमें एक s orbital, दो p orbital है, एक s orbital, तीन p orbital का है, एक s orbital, तीन p orbital का, एक d orbital का. So like that you can see the naming of the orbitals and the hybrid orbitals. Okay, you can have the various kinds of orbitals, types of hybridizations, and you can say s orbital and it is going to be p orbital. दोनों मिलके क्या होगा? It is going to be two numbered hybridized orbitals. It is going to be sp. So this is going to be one srp and this is going to be another one. This is going to be sp. It is a linear in geometry, and it is going to be linear in geometry. It will have 180 degrees angle, and we will discuss more examples based on this also. Bachcho, hope you are understanding clear? Right. Now you can see the sp hybridization. It is a linear. Danishiga, it is formed by the one s orbital and a p orbital. S का character कितना होगा? 50% होगा. And p का character कितना होगा? It is going to be 50%. ठीक है? समझ में आ रहा है क्या? अरे कुछ डाउट है ना तो जल्दी जल्दी पूछना. Make it fast. Moving ahead, and one s orbital and another p orbital, you are going to have three sp2 hybrid orbitals. So that you are going to have sp2, 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 three sp2 hybrid orbitals. It is going to be 120 angle hoga. S character is going to be 33%, 33. And P is going to be 66.66. Understand? Fine. Janisha, you are asking about S character. Am I right? Now let's talk about, it is going to be triangular planar, 120 angle can be seen. A 3 new sp2 hybridized orbitals are seen. Okay? And also it is an sp2 hybridization. So this is called triangular planar hybridization, trigonal hybridization. BCl3, BF3 comes under this, and the previous one is going to be here BeCl2 comes under this category. And talking about tetrahedral hybridization, and the next one is going to be tetrahedral hybridization. And in the tetrahedral hybridization you can see one s orbital and 3 p orbitals is going to be get 4 sp3 hybrid orbitals. It appears like this, 4 tetrahedrally arranged. It is going to be 4 tetrahedrally arranged, and the angle is going to be 109.5, and उसमें s is going to be 25% का बेटा, and p is going to be 75% का. Fine. 1/4 and 3/4, and it is going to be tetrahedral hybridization. It is going to be tetrahedral hybridization, and CH4 is the example for this. So it's very, very important. I just want to give you an example of CH4. By the time I just skip this, I want to explain this CH4 as an example. You can say carbon is having 1s2, 2s2 and 2px1, py1, pz0. So इसका पास सिर्फ 2 unpaired electrons है. If this electron is joined here, from here to here, carbon is getting excited, it is going to get 1s2, 2s1, 2px1, py1, pz1. So when happens, this is going to have sp3 hybridization इसका जैसे. So carbon is having sp3, okay, sp3, sp3 and sp3. They have the unpaired electrons like this. They have the unpaired electrons like this, like this, like this, like this, like this. Now what happened here? Hydrogen is going to overlap here with its electron. Hydrogen is going to overlap with this electron like this with the electron. Okay. So what I mean to say, carbon is going to form sigma sp3 s overlapping. There are 4 overlappings like this. Are you getting or not? Aradhya, hi, tell me if you have any doubts. Aradhya, hi. That's good. Any doubts? Janishiga, any doubts? So please like the button. Aradhya, if you have any doubts, please put in the chat box. So this is a tetrahedral geometry. How it is going to be tetrahedral geometry? If you find a line over here and connect here, and you are going to see a face over here, and you are going to see another face, the other side, it is going to be 4 faces are there, it is going to be tetrahedral. No doubts. Then you find the like. Thank you for liking the session. And you can see it is sp3 hybridization, sp3d hybridization. In this sp3d hybridization, you can have percentage of p character, percentage of s character. So Janishiga, your doubt is there. So sp3 percentage of s character is 50. Here it is 50. Here it is going to be 33.33. Here it is going to be 25%, right? And you can see. So methods for finding hybridization, determination of type of hybridization, you can say orbital box diagrams is one method, and finding steric number from the Lewis dot structure, or finding the steric number from the formula. I prefer this. Okay. So we'll see various examples after this, and I'll let you know the formula directly, and you can do it later. We can have this class. Okay. Yeah, right. Let's talk about steric number and hybridization. Steric number is the sum of the lone pair number and bond pair number. Steric number, yes, and it is going to be steric number. It is going to be steric number. Steric number is going to be number of bond pairs and lone pairs. Okay, so if the steric number is 2, it is going to be sp hybridization. Steric number is 3, it is going to be sp2 hybridization. 4 sp3, 5 sp3d, 6 and sp3d2 and 7 sp3d3. Based on that you can do it. And also you have a formula. Who is he? Linus Pauling. He is not actually related to chemistry, but he introduced hybridization concept, and he introduced some concepts in the biology. And you see, he is a biologist actually, Linus Pauling. And determination of hybridization, I just want to give you the formula, not he has given. And steric number is equal to number of sigma bonds and okay, and plus number of lone pairs of atom. And you can say you have a formula, you can just leave it, okay. You have a formula to calculate the hybridization. You have a formula, bachcho, and that formula I want to say calculation of steric number. We have a formula, right? What is that formula? You can see it is the formula where steric number is equal to V plus M minus Q, plus or minus Q, you can say it is plus or minus Q, plus or minus Q. And V stands here number of valence electrons present in the central atom, and M is the number of monovalent atoms that is attached to the central atom, and Q is the charge on the ion. Dear children, Q is the charge on the cation or anion. Okay, if the charge is there, reverse the sign. Please reverse the sign. You want to discuss the hybridization of PCl 4 plus. So steric number is equal to, okay, valency of the phosphorus is 5 and number of monovalents attached is going to be 4, and it is plus 1, make it minus 1 by 2 is equal to 4. So that it is going to be sp3. You got it? How to solve it? Dear students, you got it? Then how do you do for PCl6 minus? I want to know the hybridization of this PCl6 minus. PCl6 minus. Aradhya, PCl6 minus. कैसे कर सकते हैं? That is going to be, phosphorus is going to be 5 plus 6. It is minus 1 now, make it plus 1 बच्चों by 2 is going to be 6 sp3d. Simple. सिंपल स्टेरिक नंबर का हिसाब से आप दे सकते हैं ना, राइट? वेरी गुड, वेरी गुड. नाउ आई जस्ट वांट टू से हाउ टू फाइंड द हाइब्रिडेशन ऑफ XeF2 xenon का. Those who are online, I want to know what is the hybridization of this. Here xenon, you just say steric number is going to be, okay, xenon being a noble gas, it has 8 electrons in its outermost shell, and plus it is going to be 2 fluorines are there, and there is no charge by 2. 8 plus 2 by 2, 10 by 2 is going to 5, it is going to be sp3d. ठीक है? How simply we are doing, my dear students, how simply we are doing. Janishiga, very good. Janishiga, very good. Now I just want to say SO42 minus सल्फर का हाइब्रिडेशन क्या होगा? सल्फर का हाइब्रिडेशन क्या होगा बच्चों? सल्फर का हाइब्रिडेशन देखता इसका स्टेरिक नंबर, सिंपल. So sulfur belong to group 16, so it has 6 valence electrons. It is linked to oxygen. M stands for number of monovalent atoms. Okay, number of valence here number of monovalent surrounding atoms. Okay, it could be either H or halogens. Oxygen is a divalent, so that whenever oxygen comes, it is being taken as a 0, and it has +2 charge, it has -2 charge, make it +2, right? When you make it +2, it is going to be 6 + 2, 8 by 2 is equal to 4, it is sp³ hybridization. Hey, Kina? sp³ hybridization. Janishika, you are doing great, and Aradhya, last question of the day, CO3 2 minus carbon ka hybridization. Jaldi batao in the chat box. I'm expecting you to do. Okay, what is the hybridization of carbon in carbonate ion? In the carbonate ion, jaldi, fatafat dekhe then. Okay, so it is going to be sp². So the speed game, NEET examination, bachcho, it is a speed game. Hai kya na? Wow, fantastic. Okay, now dear children, we had a very good discussion. We started right from covalent bond. Yeah, it is sp², appreciated. We had a great discussion today. We had discussed about covalent bond, coordinated covalent bond, formal charge, kind of resonance, and also we discussed about the VBT postulates and overlapping sigma bond and pi bond, difference between sigma bond, pi bond, overlapping conditions, and hybridization and tricks that is used in the hybridization. And students, Janishiga, Aradhya has given a very good answer, Atul also. So we'll see more such kind of sessions that can give you very good insight for your NEET examination. So we are done from today here from my side. Thank you very much. God bless you. We'll meet with more stuff in the next class. Stay tuned. Thank you. Signing off, Suresh, Faculty of Chemistry from Infinity Land. Thank you, Bacho. Bye bye.